So I work for Bolton & Francis, as Stephen said. It's part of the Adesso Group, just the size of the organisation. Our turnover is around about 22 million now, 200 employees, and we're backed by an organisation called the Longacre Group, and we would consider ourselves the engineering power specialists for the Longacre Group. You can see there an organisation chart with a number of brands. Bolton & Francis is one of the brands, as with Allen West, Inspect Solutions and iGranic. Our markets are very much focused on oil and gas, rail, mining, aggregates, industry, water and steel. They're all critical power infrastructure businesses, and we would consider ourselves as manufacturers and also technology integrators in low and medium voltage, specialising in motor starting, medium voltage motor starting in particular. Over the past year to 18 months, we've been working closely with Transmag as an install partner for retrofits of internal arc protection systems. I'm going to cover a case study of one such install that is in the water sector. So, as I said, yeah, water sector application. The background story from the client was it had a failed transformer on a 3.3 kV auto transformer motor starter. If you look to the top right, there's a typical application of one of our systems, which would be a medium voltage motor starter system. And on this particular application, due to lack of service and inspections, the surge arrestor or surge diverter failed. The cause of that failure was the degradation of the surge arrestor, which happens. Surge arrestors have no real indication when they're failing. They're there to direct any surge down to earth, and they do degrade if they're continually being stressed. The typical maintenance regime is to change them every 5 years or inspect them during maintenance. This hadn't been done, resulting in a low impedance pass to earth during startup. The impact of the equipment, there was a flashover causing significant damage to the transformer. You can see that in the middle picture to the right, and also to the enclosure and to other equipment. Other equipment due to the fuses operating, there was a delay in the fuses operating, so that caused damage elsewhere in the enclosure. Luckily on this, there was no impact to personnel, as the arc was contained within the existing enclosure. Our systems are built to IEC 62271, which is the standard to ensure that there's no injuries to the operator, and all doors are held back. There's no parts of the switchgear being stressed and being projected towards the operator, and all explosive gases have to be marshalled away to the rear and upwards away from the operator. So our proposal to the client. The client had this happen a number of times. He wanted us to inspect the system as the OEM manufacturer, and we proposed to them a retrofit wall-mounted arc detection relay system with sensors installed within the panel over the replacement transformer and any power factor correction system, so that the arc detected would prevent any catastrophic failure to equipment. The installation time was round about 1 day. That was to install it, test and commission. The cost impact was only about 5% of the new replacement costs. And then that was underpinned and supported by ourselves with engineering drawing and an extended warranty on the wider system, what we installed and upgraded. Slide to move. There we go. So a quick overview of the system. On the right there is the Transmag designed wall-mounted system with arc protection relay in. The wall-mounted protection relay is built and tested prior to dispatch. We also make them in our own Adesso Group factory. So all the design and testing is done before we go to site. We take to site and we install the wall-mounted enclosure adjacent to the motor starter. Our approach is to very much try and do much of the pre-work prior to any shutdown. So that involves installing the power supply and pre-running any sensor cable and the trip output cabling. And then when we come to shutdown, all we've got to do is connect the pre-run sensor cabling and trip outputs. System commissioning is very easy. It's via dip switches. So it's setting up and configuring the unit. We'll very much take the ownership of that for the client. So that's all part of the service. And then the commissioning is very much pressing the set command and allowing the system to self-set. So what I presented there really is a wall-mounted system. We also do panel-mounted designs. The system that we installed for this water application was for pressure only, so it's light sensing only, but there is also sensors for monitoring pressure, as you heard earlier, and also we can use fibre as well. Just to show you the rear of the unit and the commissioning approach. You can see there that the back of the unit is easy to wire. It's connection of all sensor wiring to the back of the unit. We configure the dip switches and then we press and hold the set command for to commission the unit, and it's self-commissioned within a few minutes if you hold the commissioning button for 3 seconds. The customer's feedback was very much wanted to understand why the system had failed. We advised them of the surge arrestor failure. Client took time to investigate themselves, and a quick cost-benefit review highlighted the benefit of installing arc detection monitoring for a protection of equipment. And now, as an organisation, we are involved in working ongoing with this client on other 3.3 auto transfer motor starters to remove this particular risk. The lessons learned during this install is tends to be system uptime is the lever for capital investment in safety, and I say that with thoughts to engineers on sites trying to make, I've heard it today, trying to make cases for funding in safety. I would strongly encourage you to look at uptime and present the argument as uptime, because that's where that's the lever really to get the cost signed off for the investment. We very much identified the poor risk of not only surge arrest, as I've mentioned, but also power factor correction. Power factor correction, capacitor start to age. During our maintenance, we will inspect the capacitor to see if they started to degrade or show signs of degrading. But both of those devices fitted in motor starters, when they fail with an impacting event, which is tends to take out the whole switchboard rather than just the individual device or the capacitor. So the downtime because of that is significant. We've also managed to reduce system downtime, so working and very much focusing off-site engineering, ensuring that the panel is ready and all the power supplies, sensor cabling is all done pre-shutdown, that when we attend site. It's a matter of just connecting those to the panel, which can reduce it to a couple of hours. One thing worth noting is that there has been a lot in discussion in the chat about the cost of arc quenching, the cost of relays, but in general, it's very much less than one section of a medium voltage vacuum circuit breaker or one LV panel section. And how often have I been to site and looked at a switchboard and there's power factor correction sections there, and the client says, I'm not using those, but he's purchased them during the initial design and during the initial project. So finally, an investment in system uptime offers an improvement of the switchgear arc classification. In this particular case, the client was left with an asset that was a PPE class category 2, and then that resulted overall in operator safety 2, which isn't what he started off looking for, but now that's we leave site with that situation around that particular electrical asset. Thank you very much. That's my case study.